8.2 is on adding and subtracting rational expressions. Basically, it's adding and subtracting fractions. And so we need to know how to add and subtract fractions by hand, but better yet, we need to know how to come up with the least common denominator. So the first part of this A2 is on finding the least common multiple of something, which is basically the same as finding the least common denominator. So let's go ahead and just take an example, 12, 15, and 16. If I have numbers 12, 15, and 16, how do I find the least common multiple of those numbers? Now, you could just multiply them all together, but that doesn't necessarily work because you might not come up with the least common multiple. Okay, so here's how you do it. You find the factors of each number. So here I have 12. The factors of 12 would be 4 times 3 or 2 squared times 3. So we prefer to find the prime factors and the powers of those if possible. Now 15 has 3 times 5 as prime factors. 16 has 2 to the 4th power as its prime factors. Now, here's how you find the least common multiple. When you look at the least common multiple, you look at all of the different factors within all of the different numbers. And so when we find our least common multiple, what we are doing is we are taking the different factors, all of the different ones, which are 2, 3, and 5, but then we take them to the power of the largest powered factor. So we have a 2 squared, we have a 2 to the 4th. We aren't going to take 2 to the 6th, we're going to take 2 to the 4th because 2 to the 4th goes into it, but also 2 squared goes into that. So you don't need to take more than just the largest exponent of all the different factors. When I look at the 3's, they both have 3 to the 1st power. So that's all I'm going to do, is take 3 to the 1st power. When I look at 5, of course, that's the only 5, which is 5 to the 1st. We're going to take 5 to the 1st power. This will give me my least common multiple. 2 squared times 3 goes into it. 3 times 5 goes into it. And 2 to the 4th goes into it. Everything needs to go into it the least amount of times. And so when I multiply this together, I basically get 15 times 16, which I believe is 250. It's not 256. It's 15 times 16, 240. So 240 would be our least common multiple of these numbers. So let's take that concept and use it with this one, where you have monomials. You still have numbers, but you have variables as well. So we're going to do the same exact thing. So for this one, we get, it's basically the same here, 2 squared times 3 times a squared times b. Okay, so 15, again, is 3 times 5 times a times b times c. 8 is 2 cubed times b cubed times c to the 4th. So to find the least common multiple, we take each of the different factors throughout. So we have a 2, we have a 3, we have a 5, we have an a, we have a b, and we have a c. And then we take the ones out of all of these factors, we take the ones with the largest exponent. So the 2, the largest exponent is 3. The 3 is just 1. There's only a 5. A, there's an a squared and a, and so a squared is our largest exponent. B, we have a b, b, and b cubed. And then c to the 4th is our largest exponent. When you multiply this all together, that's our least common multiple. We have 15 times 8, which is 120. A squared b cubed c to the fourth. And so that's how that works. That is our least common multiple. Now, let's look at one with, here's a couple trinomials. So let's go ahead and figure out how that works. So let's take out and factor these. We've got a 4 common, so I'm going to take a 4 out. I get a squared minus 3a minus 4. And then I'm going to factor this into minus 4 plus 1. So those are the factors of this first one. A 4, or 2 squared, a minus 4, and a plus 1. Now this one I'm going to take an a out. I get a squared minus 9a plus 20. And then I get a minus 5 minus 4. Okay, so now to find the least common multiple of this, this one has a 4, so we know we need a 4 in there. This one has an a, so I need an a factor in there. They both have an a minus 4, so all I do is I take one of those because the largest exponent is 1. This one has an a plus 1, and this one has an a minus 5, so they both need to be in there as well. So that's my least common multiple, and I'm going to leave it like that. I'm not going to multiply it all together just to save some time, but we can definitely leave it in factored form. Okay, so that's finding least common multiples. Now we're going to apply that to adding and subtracting fractions. So if you notice here, all I did was I just wrote a fraction down. One fraction times another. And so this is a very easy kind of concept. If you catch on to it, it's very an easy kind of concept to understand. I'm going to do my best to explain it. Okay? So when you are adding two fractions, obviously you could just type it in your calculator, but that's not the point here because we can't just type it in our calculator with these other ones. So what we're going to do here is the first thing we're going to do is we're going to factor the denominator. All right, so this one is 3 cubed. This one is 2 times 3. Okay, the numerators just are what they are. Now, here's how I think of adding fractions. You can't add fractions unless they are like denominators. So what I'm going to do here is I need to multiply this denominator by something to get it to be the same as this denominator, and vice versa. So 3 cubed, what 3 cubed does not have that the other denominator does have is a 2. So I need to multiply both top and bottom by 2. Now, this other denominator has a 2 and a 3, but it does not have 3 3's. So we need to multiply by 3 squared to get 3 3's down here, or of course 9. Once I have common factors in both denominators, I can add the numerators. So at this point, I have 4 plus 45, so that would be 49, over 27 times 2, or 54. That would be my fraction. Okay, these are both 27 times 2, or 54. So basically what I ended up with was 4 over 54 plus 45 over 54, which gives me 49 over 54. Okay, because this is what basically this ended up to be. And now we add the numerators and leave the denominator the same. All right, so that's adding fractions. Let's do that with these types of problems with the variables in it. Okay, so we know this has a 5 and just a 5, and this has a 2 and a 5. Okay, this one has an a cubed and an a, b squared and a b. So what this one needs over here is a 2. What this one needs over here is 2 more a's and 1 more b. So you're looking at the factors and figuring out what factors this one does not have that we need to multiply it by, and then what factors does this one does not have that we need to multiply it by. So we end up with 8 over 10a cubed b squared plus 9a squared bc over 10a cubed b squared. Now we can go ahead and add the numerators. Now when you add the numerators, you cannot add them because they're not like terms. So you just say 8 plus 9a squared bc all over 10a cubed b squared. Okay, so that's how that one works. Let's try the next one. You could actually try this one on your own. You could pause the video, see if you can get it. I'm going to go over it here in a second, so go ahead if you'd like, pause the video and see if you can do it. Okay, welcome back. Now let's see. If this one is 16, which is 2 to the 4th b squared, this one is 5a cubed b, we need to multiply this side by a 5. To top. This one has an a cubed, but this one does not. So we would need to multiply by an a cubed to the top and bottom. This one does not have 2 to the 4th, but it's missing a b also. Okay, so when I clean this up, I end up with 15a to the 5th minus, that's a 16 times 8, or 2 to the, let's see, that would be 2 to the 7th power, which is 128, I believe. 2 to the 7th is 128. Yep. So this is 15a to the 5th minus 128xb all over whatever one of these are, because they're the same. Over 16 times 5 is 80, a cubed b squared. So there's my answer. All right, so we're going to use that same concept when we are adding and subtracting fractions that have polynomials in it instead of monomials. Now, one of the things I immediately do on this is I like to change this to a plus and move the negative up. Now I've changed it to an addition problem. I need to factor. So what I'm going to do is I'm going to go ahead and factor the denominators over here. This one is x minus 3 and x plus 2. This one is 5 and x plus 2. Now, to add these together, this one needs a 5 in the denominator. So I'm going to multiply the top and the bottom by 5. This one needs an x minus 3 in the numerator and denominator. Now, my denominators, 5, x minus 3, and x plus 2. I do not need to multiply all that together. The numerator is 5x minus 5, sorry about that, minus 4x plus 12. Which basically, now I can add like terms. I end up with x plus 7 over 5, x minus 3, and x plus 2. Hopefully that you can see that. I better move it over a little bit. So I went ahead and multiplied 5 to the top and bottom to get the denominator the same as this one. This one I had to multiply x minus 3 top and bottom. I multiplied the numerator here, multiplied the numerator here, added like terms. The denominator is just one of those. So there's my final answer. Let's do one more here. Let's see what we can come up with here. Again, I like to factor the denominator first. So let's take and factor this. If I can, this one's easy. It's 3 times 4x minus or plus 1. You know, I'm kind of assuming that one of these is probably 4x plus 1. Let's try it. If that's 4x, then this one's x. This one has to be plus 5. Sure enough, that works. If I FOIL it back together, it works. So this one I need to multiply by a 3 to top and bottom. This one I need to multiply by x plus 5 top and bottom. So what I'm going to do is I'm going to distribute the numerators. So I end up with, I'm running out of room here, but I'll put it over here. 3x minus 24 plus 6x plus 30 all over 3 times 4x plus 1 and x plus 5. So when I add the like terms, I end up with 9x plus 6. 9x plus 6 over 3 times 4x plus 1 times x plus 5. Now, the problem with this one is, and I'm going to rewrite this up here just so you can see what I'm doing better. The problem is I see a factor on the top that's the same as a factor on the bottom. Now, in section 8.1, you should have kind of learned that you cannot cancel terms, but you can factor stuff out, and if any factors are the same, you can eliminate them. So at this point, I have 9x plus 6 over 3 times 4x plus 1 and x plus 5. What I can do is I can factor a 3 out of the top, it looks like. Don't always be able to do that, but this one does. And now I can eliminate those. So my answer is actually this one in simplified form.